Good morning and good afternoon, everyone. This is Andrea Baer. I'm the Climate Services Program Manager for the Western Region. And welcome to our first Climate Services Seminar Series for the year 2022. We are working on getting a lineup for you guys this year. Hopefully, we'll have a little more full calendar within the next few weeks. And keep checking back on that calendar for more information. And you can also access the recordings from that registration, or excuse me, from that spreadsheet that Jenna created. So today we have the Western Regional Climate Center on, and they have a new tool called the Snow Drought Tracker that they've been developing over the last few years. And it is definitely not just a tool for the Weather Service Western region. It can be applicable to many other parts of the country. Also, they're going to give us a little bit of an update on some of their main projects and where they're going with their, a few tools are being updated, and those tools can be used beyond Western region as well. So stay tuned for those. So our speakers today are Dan McAvoy and Ben Hatchett, and they are the co-regional climatologists for the Western Regional Climate Center. And so they develop all kinds of great tools for all of us to use, a lot of emphasis on drought and other good things as well. So Dan, I'm going to turn it over to you to get us started. So Dan McAvoy, take it away, please. Oh, sorry, wait. And if you have questions, if you'd please put those in the chat. And hopefully we'll have time to have Dan and Ben get to those. So now I will turn it over to Dan.
Sounds great. All right. Thank you, Andrea, so much for the introduction. And thanks for having me here today to present a few updates and a little bit about the Snow Drought Tracker tool. My colleague, Ben Hatchett, we were going to do this in reverse order, but Ben's running just a tad bit behind, so he's going to go after me. The intent was for Ben to talk about some of the research that sort of set up and the reasoning behind the development of the Snow Drought Tracker tool, but I'll jump right into it first and kind of showcase the tool, what you can do with it, what data it uses, that sort of thing, and explain a bit about it. And then I have a couple other updates about some of the Western Regional Climate Center tools that I will also share. And then when I'm done, Ben will come on and explain a bit about the research directions behind the Snow Drought Tracker. So I'm gonna do everything I'm gonna be doing pretty much is a live demo here. So I do have some screenshots as a backup if things don't work, but I've been testing things this morning and they seem to be working fine. So hopefully you're all seeing the Western Regional Climate Center homepage. This has been the same homepage for a while, but one main update is that we're in the process of basically rebuilding this entire website. So this is now being referred to in-house as our legacy website, the WRCC.dri.edu. And you come to that homepage, we have a link up here showing us that, or telling you that we're in the process of building this new website with a new look and feel, a more modern feel, and more modernized tools, some new tools and some recreations of some of our existing more popular tools. And so when you go to that new link, it's the same the same link, but on the end you have a /my. It brings you to this page here, and so this will be the landing page when you go to that site. And so there isn't a ton available on this site yet. Again, it's still in development, and this is a several-year process that's underway at the Western Regional Climate Center. We have a new team of software developers. Really for the first time ever that the WRCC has had dedicated software developers or software engineers. So this is great. We now have 3 full-time software developers strictly dedicated to working on the rebuild of this new website. And so one immediate thing that you'll notice well, maybe I'll log out just to show you because it has confused some people already with this new site. So I'll log out. And yeah, so you come here, you're going to have to create a user account to access any of the new WRCC tools. We want to do a better job of tracking who is actually using our data. And so I'll log in. And so then you'll land here. And so it's a free account you set up. And so we'll have our station products. So this will be our station viewer, where you can look at all the historical co-op data and the RAWS data. The whole RAWS page is going to be rebuilt, as well as the co-op station viewer pages, but none of that is ready quite yet. But what I did want to focus on are a couple of apps that are ready and available from these new web pages. And so I'm going to start with the Snow Drought Tracker, which is the main focus of the webinar today. Then I'll talk a little bit about the state climate trackers and see how much time we have. I might mention one other tool, which is Climate Engine. And so let's start out with the Snow Drought Tracker. So this is the interface of our Snow Drought Tracker tool. And so the whole idea behind this is right now it's currently run on the SNOTEL network, which is a network of weather stations across the western U.S. mountains and Alaska. We do also have Alaska available as well, which is great. And so these stations are located in mountain areas across the West and Alaska. And they were primarily put there to monitor the snowpack. They measure snow water equivalent. There's snow pillows for snow water equivalent and snow depth. They also record precipitation and temperature, and some of them record humidity and wind speed and soil moisture. But the main focus of this tool is the precipitation and the snowpack data. And so I just want to go again. Ben was going to set some of this up, but I'll go and show you. If you go to the help down here on the left, whoops, not the help. If you go to more and the about section, and keep going way down. Okay, so the main new product on this tool are what we're calling the snow drought phase diagrams. And the idea here is to track snow droughts through time. So snow drought is basically an anomaly, a below average anomaly in snowpack. And so there's been quite a bit of research in the last 5 years since the big Western snow drought in 2015 on how to track these, how to define them, what data sets to use, how to visualize these things. And so what was unique about the snow drought in 2015 that caught a lot of, at least researchers' attention, was the fact that in places like the Pacific Northwest, in Oregon and Washington, if you looked at their water year accumulated precipitation for the year, you would see that it looked to be around average or even above average in some places, yet their snow water equivalent and their snowpack was near record lows. And so it's this idea that you can still have precipitation that is near average, but have snowpack that is well below normal due to increased temperatures, more rain falling as opposed to snow during the winter time in the mountains. And so typically these things have been tracked separately. You can look at, time series of snow water equivalent overlaid on, the accumulated precipitation time series. NRCS has some wonderful tools through the SNOTEL network to track those two separately. But the idea for these snow drought phase diagrams was really inspired by the MJO, the Madden-Julian oscillation phase diagrams, phase space diagrams. And so this is an example, and I'll go through these on the website in a minute. But what I wanted to point out, the first few times you see these phase diagrams, the interpretation can be a little bit tricky. Most people are not familiar with how to interpret these. And so Ben developed this conceptual diagram basically showing that what this will do, these phase diagrams will start on October 1st, at the beginning of the water year, the Western water year, and they'll track on the horizontal axis, they'll show the percent of average, or, I'm sorry, the percent of median accumulated water year precipitation each day. And so this will be a daily, each day another dot will be added to this phase space diagram. And then on the vertical, you have the daily snow water equivalent percent of median, so you can track them together through time. And so you wind up with these four main quadrants, with the bottom two being the snow drought quadrants, and then the top two quadrants being your above average snowpack years. And what I was referring to before with these warm type snow droughts where you have near average precipitation but well below average snowpacks, those will be plotted up in the lower lower right quadrant of the diagram. Over here where you have your precipitation anomalies that might be, 100% of average, 125% of average, but your snow water equivalent will be well below average, 50% of average, something like that. And then on the left here, you have the lower left quadrant, you have your, it's been termed, there's still some debate about the terminology of warm snow drought, dry snow drought, regular snow drought, what you want to call this. But this is more of your meteorological drought in the lower left, where your lack of snowpack is due to your lack of precipitation. And the closer you are to this 1-to-1, the closer the precipitation anomaly is to the snow water equivalent anomaly. And so this is the main feature of the Snow Drought Tracker website. We do have some new additions that where we want to incorporate that I'll talk about, but I do want to get to the tool itself. And so here's your interface. These are all clusters of SNOTAL stations, and as you click on the clusters, they reduce in size until you get to your individual stations. And so you can find a station if you know exactly where it is using the map, or you can let's see, where is my station selector? There it is. So you can actually type in a station, and so if you wanted to look at the CSS lab, this is the Central Sierra Snow Lab, which is one of the benchmark stations in the Northern Sierra Nevada near Lake Tahoe. And so you click on these stations, and you basically, you need to add it to your dashboard to view it. So when you're on the map, you click add, and then you go to your dashboard, where this will display all the information for the current year. And so on the top, you have the almanac, and I noticed this morning. So this is displaying the latest data, is showing January 10th, which is a bit lagged here. And so this tool, as well as many of the tools at WRCC, are relying on ACES to pull the data. And I did check in ACES this morning, and their last update of the SNOTELs was on the 10th. And so there's usually only about a 3 or 4 day lag, but this is much longer than that. So we might need to check in with the ACES folks on that. But you get your almanac, so you get your daily values, your precipitation for the day. I'm not sure why these are showing missing values, but you can also get month to date for precipitation. So for January, this was through the 10th. It's still been very dry in this location, 25% of normal, year to date, and then of course water year to date numbers. And then you also have your phase diagram, which is the main feature here. And so this year, this example is for the Northern Sierra Nevada. I'll show a couple other locations and examples. And so this is plotted daily, but to reduce the noise on these graphs, it only shows a dot once every 5 days because it got pretty crowded when we were showing all the dots. And again, we have accumulated precipitation, percent of median on the horizontal, and daily SWE percent of median on the vertical. And so each dot is plotted and each month is shown in different colors. So we have starting in October in the light blue, November in the gray, then December in the purple, and January in the gold there. And so we started off with this very huge precipitation anomaly in October with the atmospheric river. And so we started in this top right quadrant. And these are capped at 225% of median on both ends to avoid these huge anomalies that would really skew the visualization. And so the precipitation anomaly was far greater than 200% of normal. You started in this upper right quadrant. There was a little bit of snow, and then the snow melted in October, so we quickly dropped down to this lower right quadrant where the precip was well above normal, but there was no snow in November, which was dry and warm. And then we got into December, and we got these huge snowfall events, good precipitation and good snow. And by the end of December, we're back up here in this right quadrant where both precipitation and snow water equivalent were well above average. And then you can see the beginning of January, it's beginning to dry out a lot, but by the 10th, we were still in pretty good shape. And so a few options with these, you can pop these out. And so you can save these as a PNG or an SVG. And you can also download the data and do whatever you want with this on your own. And so you get a CSV, which actually gives you the daily values, gives you the SWE, the snow water equivalent. It gives you the departure and a percentage, or I'm sorry, that's the normal, it gives you the normal value. Then it also gives you the departure and a percent of average. And same thing for precipitation. So you can do what, if you wanted to do your own processing or analysis with that, you can grab those. And so that's the dashboard, which tells you about this current year. But then you can also look at any historical years that you want. And so to look at historical phase diagrams, you'd select for variable, this would be SWE and precipitation. We also have the option just to look at the raw data from the SNOTEL stations, the precipitation, the temperature variables, the snow depth, and the snow water equivalent. And so again, you can get the data, or you can plot the time series for the station. And you know, you can plot several years if you want. So if we go back, say to the beginning of 2019, if you want to look at multiple water years in a row, and then we'll go through 2022. I think 10 was the last day we had. And so you can get these daily time series. And again, you can download the data this way, or the graphics if you want. These are interactive charts, so you can click on them and get the value in inches of snow depth. And again, we also have the temperature and precipitation and snow water equivalent available. But let me go back and we can look at a historical phase diagram if you wanted to look at some other wet or dry years. So again, this is daily. You put in the start and the end date. And so if we go back to, say, the 2015 water year, so 2014, we start at October 1. And then if we go to 2015 through, say, the end of April to look at that whole season, you can get these historical phase diagrams. And so what you see here are, again, the different colors, October through April. October gets pretty noisy. And so one thing, if you see something like this, you might realize, well, it doesn't make a whole lot of sense to start these in October. You might want to start it in November because the SWE is so variable. In October, you can go back and say, actually, I think I want to start this in November instead. So you can change those pretty easily. to reduce the noise of the October snow water equivalent variables, and still gives you the same signal. And so this was a very bad year for the Sierra. But even, in December here, we had precipitation that was near average, yet we had snow water equivalent that was down, at 42% of average or median. Well, precip was 99%. And then in the spring, then things got really bad. And by early April, there was no snow, yet we had 56% of average, percent of median precipitation. So this was kind of those merged warm and dry type snow droughts there. And again, you can maybe show an example for Alaska to show that we do have data available for there as well. And one thing to note, if there is less than 30 years available at the station, it won't have a climatology to use for these. So some of the newer SNOTEL stations, this won't work for. We're working on incorporating so we're computing our own normals with this tool. And so we're working on incorporating the NRCS normals, which actually does have normals for some stations that have less than 30 years of data. They have a method they've developed, they have confidence in to provide normals for some of those other stations. So this is Turnagain Pass in South Central Alaska. And so the same thing here, we have same type of dashboard. And so they in South Central Alaska started out with big, much above average precipitation as well as snowpack, and that's sort of been trending down towards more average snowpack and precipitation conditions. The last value here is showing from the 5th of January, which was showing SWE at 100%, 17% of median, and precip at 118% of median. This GoToWebinar is flashing at me for some reason. Not sure why. Okay, so that was sort of a very quick overview of this tool, and I did want to show a couple other updates. So I'm going to just go back and briefly touch on a couple other things so we have time for Ben and also for questions. The other app I did want to show that we do have available now is our state climate trackers. And so this originally started out at the WRCC as just the California climate tracker. And I think for a while we had Nevada as well, but we never had all these other states. But now we have them for all the Western states. And so if you click on a state there, this tool is run off of the PRISM data set, gridded data. And so this will give you information about temperature and precipitation from PRISM. And so this also has a dashboard. This is displaying, I believe, the climate divisions, NCEI climate divisions, and these are all interactive maps. So it'll give you on the dashboard the last month available, which is December. So this is showing the December 2021 temperature anomalies and precipitation anomalies at the climate division scale. It also shows you the statewide choropleth map, which is just a box for Colorado. We also have these options for 12-month summaries, which tell you about the previous 12 months in relation to the medians, and then ranges of percentiles for both temperature and precipitation. You can get time series for all of these variables. So this is all the December statewide mean temperatures, and so you can update your variable or your location. So if you wanted to look at precipitation instead, you can update all that on the fly. Again, these are all interactive. You can pop these out and download the graphics or the data as well. This is a new type of graphic for these climate trackers, these checkerboard plots, which show all the months and all the years and the shading is the anomaly. And so you can look for trends in things like precipitation and temperature anomalies. And you can also go make your own customized, again, historical one for any of these. And so I'll just show maybe one example of a map, of a mapping example. And so right now we have statewide climate divisions and also counties available. So I chose counties, and we'll look at precipitation. And we have percent of average, percentiles, the raw values, or just the averages. And so let's look at percentile chloroplet map, maybe water year, and we'll look at the most recent one, which was the 2021 water year. But you can put in any water year here going back to 1895 based on the PRISM data set. And then it'll generate on the fly these county level percentile rankings for precipitation. And again, this is interactive. You can click on it and get the value. Or again, you can save it as PNG or an SVG if you wanted to share it in a presentation. These are quality graphics that you can share. And so, whoops, need to have that up there. So that was a quick overview of our state climate trackers. One other WRCC tool I did want to mention is the West-wide Drought Tracker. This has been a fairly popular tool where we have drought indices. We have the PDSI, SPI, SPEI, as well as climate information, temperature and precipitation, anomalies and percentiles for given time periods. This tool has been around since about 2010. There are a number of things that don't work correctly that have been neglected due to both staffing and funding issues related to this. But just recently, we did receive funding. So NIDIS is supporting us to completely redevelop this West-wide Drought Tracker tool within the new Western Regional Climate Center framework. So we just began working on that and hope to have the initial mapping tools for the new West-wide Drought Tracker done, or at least a beta version done by the end of this year. And so I'll look for that. And I was going to talk a bit about Climate Engine, but I want to make sure we have some time. So I think it's already 12:30, so I will stop there for now. And pass it back to Andrea, maybe?
Yeah, but Ben has arrived, so should we take a quick detour back to the Snow Drought Tracker? He was going to talk a little bit about the science of it and the history. There we go. Thank you.
Cool. Thanks, everyone. Yeah, sorry we were out doing some training some second graders on various types of snow measurements, snow albedo and SWE and snow depth. So fun stuff, but managed to sneak back over to the computer to share our latest findings on the Snow Drought tool. And so I think it was helpful to have Dan give that initial introduction to the tool and the more of the operational side of it. And so now I will share some of our kind of research findings and hopefully give you some other applications and ways to think about implementing this in your workflow, and particularly utilizing the tool, and give you some ideas of how to work with partners to share the tool and have them communicate information about snow drought conditions or other hydrologically or recreationally impactful outcomes as the winters progress. And so our paper was just recently, last week, accepted for publication in Natural Hazards and Earth System Sciences. And so there's a link here, and we can drop another link in the chat. And so if you go to this link now, it'll give you the preprint version, but in due time, the fully typeset accepted version will be showing up on the website, and you can freely use that, cite it, read it, and give us any feedback. And so the main goals of our paper were really to kind of highlight both this new phase diagram inspired by the MJO phase diagram plots, and then kind of highlight some of the new applications of snow drought into mapping it in a more of a spatial sense, and thinking about it both in terms of the broader Western US context, but then also applying it to watersheds that may not have snow-tell stations or other instrumentation to create points for analysis. So the goal of the paper really was to highlight a few of these case study applications. And so there's 4 key regions that we looked at. A lot of focus was on the northern Sierra Nevada, because that's kind of where Dan and I are most familiar with. We looked at some hydrological impacts in the Cascades. The Wasatch we use as an example of showing why a percentile approach is likely more powerful than a percent of average or percent of median. Of course, knowing that percentiles can sometimes be a little harder to communicate, but they add a lot of statistical power because it sort of puts everything on the same playing field and also allows connection to the US drought monitor categories. And then we also did a quick example in the San Juan Mountains.
Hey Ben, this is Jenna. Can I just interrupt real quickly? Because we're only seeing the slideshow. Well, we're seeing the PowerPoint, not the actual slideshow. So,
Oh, interesting.
can you either end the slideshow, and then I think you can either go in and say don't use presenter mode, or you can, or I can even take presentership back and give it back to you, and then you can switch and select the proper screen.
Yeah, let's try. So if I open presenter mode, and maybe if you take it away and give it back, that will work.
Yep.
Sorry about that.
Yep, no problem.
Okay, so if we do, oops, PowerPoint. How's that?
Perfect.
Cool. Okay,
sorry,
so
we weren't keeping up with where you were. I didn't know what slide you were on.
Yeah, so we have our nice motivating slide of why we study snow drought, because you can be skiing amazing, lots of snow conditions high in the mountains, and then meanwhile down 1,000 feet, there's almost no snow. So that's kind of a new and interesting thing that's happening in the West now as we move towards a low to no snow future. So I think the only thing you missed was just our background slide on the locations that we looked at. So northern Sierra Nevada, Cascades, Wasatch, and then another example from the San Juans in southwestern Colorado. And so we're largely here going to focus on northern Sierra Nevada, Cascades, and the Wasatch, starting with the Wasatch and our motivation for percentiles. And so like I had mentioned, using snow drought categories based on percentiles is really nice because it allows us to leverage the drought categories from the US Drought Monitor. And so we can talk about being in D0 snow drought, D1 snow drought, D2 snow drought based on percentiles, which puts every station or location on a level playing field. And so looking at things in a percentile space is very close often to the percent of median, but there are some interesting cases where these somewhat skewed distributions show up differently. And Dan also mentioned this idea of being in sort of both warm and dry snow drought. So if we remember that our lower left quadrant is our dry snow drought and our lower right is our warm snow drought, even within the dry snow drought, we added a dashed line to kind of highlight when you might be in general dry snow drought, so below average precipitation, but you might be skewed to the right such that you have less snow for the given amount of precipitation that one would expect, or maybe a little bit more snow. And so that kind of just helps visually connect you to where you are in the season as time goes by. And so slightly different color scheme here, and we're working to update now that the paper's all done. We'll be updating the web tool with the correct color scheme so everything matches up nicely. And so for Utah, there was a very interesting avalanche event, a very tragic event that occurred last year. And we thought this was actually a really good example to highlight how snow drought played into that. And then also it really brought out this concept of, oh, percentile versus percent of median can tell very different stories. Being from California, I'm very used to low percent of average means almost no snow. However, in Utah, tends to be a lot of snow even when it's fairly low percent of median. But percentile wise, you can get a very different number that takes place. And so that figure on the right really shows the differences in terms of SWE percent of average versus percentile. And when we may not be very low in terms of percent of median, but percentile wise, we can be substantially lower. For example, at the time of snow drought onset, just in the early part of December, if you told me we were at 85% of median, I probably wouldn't be too concerned. However, knowing that that's actually the 30th percentile, that's very different. And that was a kind of a surprise for me and maybe for some others that we've talked about this with, of these big differences. And so I think that's a nice example of why percentiles are fairly powerful in looking at snow drought. That said, percent of median is very widely used, and I think a lot of people will get good information out of that. So you can kind of go back and forth, and that's one piece of functionality we hope to add to the tool as well, so that you can switch between the two. Nice application, I hope, of the phase diagrams is really to tell the story of how the winter worked, and being able to take a phase diagram and at any point in the year being able to annotate it and highlight different kinds of events that may have had different impacts, and tell the story of how we ended up where, or got to where we are, and how we might come out of that, or how things evolve throughout the course of the season. I think that's hopefully a helpful approach to sharing this information with partners and having them be able to explain what that meant for them, what kinds of information that they might gain from using this phase diagram approach to understand where they're at and where they could go. And then so an example of that is for Central Sierra Snow Lab on the left-hand side there. And so lots of big, interesting jumps in conditions took place during that water year 2020. And so we can kind of think about that in terms of longer term hydroclimate conditions, but then you can also see the impacts of singular storm events that really led to substantial jumps. A couple closed lows really helped us out a lot in the spring. And then on the right is sort of an updated version of a plot Dan showed, where we put in some potential interpretations of trajectory directions. And we're of course open to more suggestions and more observations from you. And just ways to, when the trajectory is going in a given direction, what might be causing that? And what could that tell us about given conditions? How could we also implement longer lead forecasts and start moving into taking the current conditions and extending them to include forecasts of even short to medium range or even subseasonal scales, to kind of get an idea of what's our likelihood of coming out of snow drought or falling into snow drought. So one example of using these diagrams is we can look at the same year, but across a precipitation gradient. So moving from left to right, moving from lower elevation or middle elevation to slightly lower, but very close. And then also moving up further into the rain shadow of the Sierra Nevada, and then jumping up higher at Mount Rose ski area. And so you can see similarities between several of the plots, but then substantial differences as well. And so that really highlights how snow drought can vary substantially, even in the general region, as a function of both elevation, which controls rain and snow partitioning, as well as precipitation totals and how much a given station can recover. So if you note Central Sierra Snow Lab in late spring, we really didn't see as much of a recovery as the Tahoe City Cross did. And then throughout much of the winter, you can see how snow drought conditions didn't take effect until a little bit later at the higher elevation, so generally colder region at Mount Rose. So a few examples that you can do there. And that's one hopefully powerful application of this, is to be able to take different stations from different locations and kind of get a broader climatological context of what was happening in a given year. Hydrologic implications, the tool is pretty interesting in that you can link it with stream flow and get an idea of how a year with similar snowpack in terms of SWE distributions, both in space and in percentile space, although slightly, well, maybe substantially lower in the warm snow drought case. So Dan mentioned the 2015 water year snow drought in the Pacific Northwest, very, very warm snow drought, lots of precipitation, very little snow. Comparing that to, furthest on the left, water year 2001, a kind of classic dry snow drought. And hydrologically, this is very interesting because in the warm snow drought, wet but low snow, we saw a much earlier peak in reaching the 50% of total annual discharge at the along the Nisqually River, just in the little bit to the west of Mount Rainier. In the dry snow drought, situation, even though there was less total discharge overall, the point at which half of that water came out of the watershed was substantially later into the spring. So it was a dry but fairly cold year. And so there's various implications that that may have for fisheries or reservoir management. I know in the Pacific Northwest, a lot of the reservoir management is really focused on hydropower. And so when that water comes out of the system can have some fairly substantial impacts on downstream use. And so we hope that the phase diagrams can help tie into some of those applications and help us get an idea of where we're at, where we're going, what could happen moving forwards. And then plots on the right just show that spatially, in terms of snow water equivalent differences from the median, these 2 years look fairly similar, but very different in terms of precipitation totals. We also showed an example of how this approach appears to work reasonably well when applied at the basin scale. So the 2 panels on the left side are both SNOTEL based plots, and the 2 panels on the right-hand side are using the University of Arizona spatially distributed snow water equivalent product. And while we do see some differences, we see general similarities, which gives us fairly good confidence that this does a reasonable job at being applicable to basins that may not have SNOTEL or other types of instrumentation. So even if you're in a watershed that has no station-based data, using these spatially continuous distributed snowpack estimates, and here we use the University of Arizona product and then the GridMet product for precipitation to estimate precipitation and SWE, could be helpful. I'm sure it will work better in some places and less well in other locations, depending how the products are developed, but it does lend us confidence towards this being applicable in regions where we don't have that data. And one example we tried was moving now to the Northeast, the Susquehanna Basin, very impacted by snow, as well as rain on snow, and notable for its rain on snow or melting, melt out floods. So we applied a couple examples there to show a few different types of years, fairly reasonable results as well. And some of those years that had very large accumulated snowpacks also corresponded to very, very large flood events. So notably that water year 1994, there was a very large snowpack that also melted very quickly and produced some substantial downstream flooding. So this approach appears reasonable for basins without instrumentation. So we hope that that will be applicable in a lot of regions where there's little to no data. And then our spatial application is calculating dry type or warm type of snow drought, and then applying that to across the Western US to kind of get an idea of through time how snow drought, both in general snow drought, just below average snowpack evolves, but then also the type of snow drought you're in, because as we saw in Washington, having a lot of precipitation, low snow can lead to notable runoff differences compared to a low precip, low snow year. And so 2015, good example of how some of these locations really evolved in time. You move from very, very warm snow drought type conditions in, especially say the Pacific Northwest, but then by moving into February and later into the spring, we started just moving into a dry type of snow drought, which is interesting to see the spatial manifestation of that. And then in the bottom left-hand corner, quick example from comparing the Sierra Nevada to the Uinta Mountains. Note that both are dry type snow droughts, but note that the elevation gradients are basically flipped. In the Sierra Nevada, as you increase in elevation towards kind of the center of that northwest to southeast trending mountain range, conditions improved with elevation, so we got more snow up high. But in the Uintas, you can actually see that as you increase in elevation, snow drought conditions became worse. Process-wise, why that occurred, you can now start to open up those kinds of questions, which we think is going to be something of interest to study as we move into these high elevation regions where we may not have data, and we also want to look at things like sublimation or rain-snow transition elevations. And then on the right-hand side, going backwards a little bit to just purely calculating percent of area in snow drought throughout seasonal snowpacks throughout the Western US, we can break that down by different category and look at how that varies for different key points in time. So kind of early to middle winter, more important, say, for recreation. And then as we move into March and April, that's where we start thinking more about water resources applications, can look at trends, whether or not those are reasonable to do at a large scale, we can discuss, but it does offer one way to kind of get an idea of, are we seeing more frequent snow drought across the West, what % of area is being occupied by given categorizations of that snow drought. So with that, I'll finish there, and we are extremely encouraging of feedback. We would love to know where this works, where it doesn't work, how this may or may not help you communicate with partners. Any feedback from them is also appreciated. Other visualization ideas are welcome, and then please use and break and report what you find issues with our web tool. And then again, there's that link to the paper, which will get updated fairly shortly, and I'll put that in the chat. So with that, thank you very much.
Okay, thank you so much, Ben and Dan. Jenna, do we have questions in the chat box?
Not yet. So people, if you have a question or a comment, please put it in the chat and I'll read it. It'll come through. I don't see any right now, but I guess I do have one, item. And I think, Ben, you had said that you would drop the link in the chat. So if you could do that for everyone, and then they can have that. And then also, I had a quick question. Maybe I missed this from Dan's earlier presentation, but the phase diagram, the interpretation actual diagram, is that on the web somewhere, or how do people access that?
Yes, that is on the website. It is in, I even had trouble finding it at first. If you're on the Snow Drought Tracker, on the landing page where it shows all the stations, there's a button that says more, and then it has an about link. And so if you go into that about section and scroll down, you will find that that interpretation conceptual diagram of the phase diagram there.
Okay. All right, we have one question that came in. Hold on a second. Oops, there's a first. The WWDT is a nice tool. Will the new upgrades take advantage of daily data instead of monthly?
Oh, that question's been coming up, has come up a lot over the last several years. The current, the first roundabout, the first year of development will not include daily data updates. That will essentially replicate the monthly data updates that are available right now. Part of the challenge with the daily data is then you have however many times more data points as well as options for things you can do with daily data. And so we are looking essentially to add on to the state climate trackers that I was showing, but update that with daily updates and have a focus on looking at extreme metrics with that. So using daily data and incorporating metrics of daily extremes for temperature and precipitation. But to get back to the original question, the first year of funding for the West-wide Drought Tracker will not include daily data updates.
Okay, I don't see any. Oh, wait, there's another one that just came in. Give me 1 second to get it loaded. This one's a bit longer, so give me 1 second. Gotta resize here. Okay, thanks for sharing. This is really cool. Can you use the Snow Drought tool to combine multiple stations for like an index over watershed? That's the first question. Second question is, have you thought about ways to depict time on the phase diagrams a little better? The colors of the months are great, but within a month, how can you eyeball is a point is for the first 10th or 30th day of the month? Do you understand that? I hope you can understand that.
Yeah, I think so. I think I can start, Ben, and if you wanted to add. So the first question was, about basically having a basin scale plot with all the stations. So Ben showed some examples of basin scale with gridded data. One of the things we do want to incorporate, and so I had mentioned there were a few additions we were hoping to incorporate to the Snow Drought Tracker tool. One is a basin scale option. So with that, you would be able to overlay different different HUC levels, you know, HUC 2, HUC 6, HUC 8, river basin scale, and then that would select all the stations within the basin to create a basin averaged phase diagram. So that's not available yet. Hopefully that will be coming. And another thing we will be adding within that basin scale. So let's say you pick a basin and it has 15 stations. Another thing that can tell you a lot about snow drought and also relation to the hydrology and other processes is the relationship between the SWE and precipitation and elevation. And so you would select a basin and there would be an option for a scatter plot that would show the percent of median or the percentile snow water equivalent plotted against elevation of the station. And then you would have the dots shaded by the precipitation anomaly. And so those are a couple of basin scale options that we do plan to add that are not available yet in version 1. Oh, and then the second question was about displaying the time better. I don't know if I have a good answer, a good solution to that at the moment. We've talked about that because it is tricky to see. One thing we did, at least on the live tool right now, as I mentioned, the line that is displayed does trace through every day, but it only shows a dot for every 5th day, which makes it a little easier to see because it got pretty noisy there. On the dashboard, it's all interactive, so you can click on the dots and see the dates, but I would be very open to suggestions on how to improve that. And then Ben, I don't know if you had any other thoughts on that.
Yeah, I think it's a challenge just with the number of things and the scale at which they're shown, at least kind of on my like more research based tool, because it's like you start putting in day of year numbers or day of month or what have you, and then it just kind of turns into a bunch of jumble of numbers. So it's definitely something we've thought about a bit and struggled with, and so it's also good to hear this feedback that would be nice. So we'll keep thinking about that. At the moment, the probably easiest way is you kind of just have to trace the colors to say, okay, when did that color jump to the next kind? Okay, that's the beginning of the month. And I know this is not a very good answer because when they're all jumbled together, it gets really, really tough. But I think with a more interactive tool where you can kind of zoom in as well, that should help. And then if you hover over and that highlights the date at which that took place, I think that would be a nice way to do it. And then with the more of the research type plots that I was showing, the goal I think is to provide the source code, and currently it's in MATLAB, but I think it'd be nice to also give in Python and maybe get someone to code it up also in R, and then that way you will have control over how the plots are made. And if you want to only show certain days or highlight different days within a month through some other creative way, that's kind of basically up to you. And we'd also be interested in creative ways to come up with better ways to visualize that. But yeah, short answer is don't have the best way to do it because it just always got kind of jumbled in our experience playing around with this. But definitely something, good suggestion to improve on.
Okay, great. Yeah, I guess you guys are looking for some feedback, so this is great. Another question came in. Any plans to work on California or to work with California DWR snow surveys to get their network of snow pillows into the Snow Drought tool?
Yes, that had been on our list as a possible addition since unfortunately the SNOTEL network only covers the Northern Sierra and a very small portion of the Central Sierra, whereas the DWR snow pillows extend the entire north-south length of the Sierra. And so it is something we've been thinking about. We haven't incorporated it yet, but it would be great to include those if we could manage to get the data. The database where we want it and the format we need it. So that's not in ACES. And so this tool right now is hitting ACES to get all the SNOTEL data, but that does not mean, of course, we can't use another option to feed that into the Snow Drought Tracker. So great suggestion, and it's something that was on our list to potentially add.
Yeah, just to add a little bit, one challenge with the snow pillow data is the quality control QA/QC aspect can be a little bit different because it's a different network and they kind of have different sensors, and so that can add a little bit of a challenge for us to just kind of, with NRCS, we can just pull it and we have good trust in all of their QC daily data that comes out, whereas I'm not sure with the DWR data if that is immediately QC'd or if you have to do your own QC to it. The other challenge with the DWR snow pillows is the period of record to calculate percentiles or percent of median. And some of the stations are probably getting pretty close to having a reasonably long record. And of course, we could still calculate this with the available records. But if you start looking at stations, once they've been QC'd and what that data period of record looks like, that might limit some of the stations a little bit. But that was kind of one issue that we wanted to sort out with DWR, because I think that's a really great comment that would add just a huge amount of information, especially to California, where many of the stations, SNOTEL stations, are in just a really finite area. There is another gridded product that should be coming back online out of UCLA and Steve Margulis's group that is based on Landsat and compares pretty well and is kind of a benchmark for a lot of modeling studies to compare against. And that's another direction I think we want to go with this, is to be able to incorporate multiple different sensor networks as well as gridded products into the tools.
Okay, great. Thanks, guys, for the answering all the questions. I don't see any more at this time. Andrea, do you have anything that you want to say to wrap up, or do you have a question? We only have a couple minutes left.
Sorry, finding the mute button. I just have one quick one. So I liked how on the graphics Ben showed in his presentation, you had the drought monitor levels. Is that available in the actual tool? I can't remember.
So it is currently not available in the tool because the tool is based on percent of median, whereas I suppose you could calculate what percent of median for each given station corresponds to each drought monitor category. So I think, Dan, maybe that's something we can bring up in our next update meeting, whether that would be available, because it would be really cool if each plot, regardless of which, even if you're looking at percentiles or percent of median, if both of those had scaled bars so that you can say, oh, this is extreme to exceptional snow drought going on right now, with regardless of what the y-axis or x-axis is.
Yeah, and we have talked to the developers about also adding the percentiles, which we really want to do, and they seem to think it would be pretty reasonable and straightforward to basically go to the dashboard, and then you have the option to pick percentile or percent of median. So hopefully in the second iteration that will show up there.
Okay, thank you. It is the top of the hour, so I don't want to, I want to respect everyone's time. But thank you so much, Dan and Ben. We really appreciate all your efforts, and thanks for talking with us about this today. If you do have comments and you didn't get their contact information, you can always send me or your CSPM in your region any sort of comments or suggestions or ideas for this, and we'll make sure we get those to the Western Region Climate Center. So thank you everyone for your attention today, and appreciate our speakers. Have a great day.